So moving on to expertise, we're going to talk about having a great deal of memory. So we've been talking about long-term memory and encoding and all these special processes. Now we're going to move on to what makes us very good at memory, which is an expertise. So a little bit on the brain and what happens to the brain when you gain an expertise, how you actually gain an expertise, and then what that does outside of the brain to like problem solving, working memory, and things that expertise is sort of tied to. So when we first learn how to do something, it takes a whole lot of the brain to do it. So it's sort of very deliberate processing, and your brain tends to have to work a little bit harder because it's new. So I'm going to talk about expertise and use a lot of athletic sort of examples, playing an instrument, playing a sport. It doesn't have to be. That's just the easiest way to think about it. You could think about getting your PhD as an expertise. So learning a lot of material. Let's say they study a lot of physicists and chess players in this sort of research, but it doesn't have to be a muscle movement memory. That's just the easiest one to kind of use as an example. Okay, so it takes a lot of the brain to do it. So think about when you were trying to learn how to write as a kid. That was a really complicated, hard process. If you think about learning to type or learning an instrument, that sort of thing. As you gain the expertise, less and less brain activation is seen. So what happens is the brain sort of figures out the optimal pathways for the best processing, so you get less and less activation the more you gain the expertise, the better you get at whatever you're doing. So it's less mental energy on that task. So you don't like to think very hard, your brain is going to do it the quick and easiest way possible. So what does it take to gain an expertise? How long do you think you have to work to get your expertise? It's about 10 years, and it's a lot of hard, deliberate practice, but 10 years of practice. So think about the first time you tried to learn how to write or to write your name, and then where you're at now, even with messy handwriting, that took about 10 years to learn. So you learn it in about grade school. And, you know, there's some give or take depending on what we're talking about. Clearly it does not take you 10 years to learn how to drive a stick shift, but this is for things that are like complicated, like learning how to write is actually kind of complicated, or learning chess. With deliberate practice, that's what's required to become an expert. The practice is highly motivated and self-monitor. So there's a check. Am I doing this right? Okay, how can I fix it? Do I have the right information? Okay, let me learn the new information. So the sort of interesting thing to me about being in academics is that, oh God, I hate writing. You would think that somebody who hated writing would not go into a field where her job depended on her to write intelligent-sounding things, but here we are. So that is a skill that I have slowly gained that requires a lot of self-monitoring. So going back and rereading, looking at things like getting someone else's perspective, and think of, you know, so it's a very highly motivated practice to be able to write in the scientific style required for my job, because it's so, I would say boring, but so technical. Okay, so lots of deliberate practice. The good thing for no talent hacks like me is that it's not necessary. Expertise is actually related to the amount of practice you get. So Andre Agassi is sort of famous for saying he had no talent at playing tennis, he just worked really hard. And while talent can help, it only gets you so far. After that, it's all about the practice, which is good. That means lots of people can develop expertise, you know, given certain cognitive and muscle limits. So why is it deliberate practice? Well, what's happening in deliberate practice is you're growing more neural connections. It's not quite as simple as what I have on the slide as growing more neurons. So remember, we had our terminal buttons and our synapses with the dendrites of the next one. What happens is you're going to gain more buttons to synapse connections, or buttons to dendrites connections, and then gain more connections between things. So you're getting more neural density But specifically, this is kind of cool, in the area for the expertise. So people who are skilled typists tend to show more neurons in the fine motor control areas of the brain. People who are multilingual show more neural connections in the temporal and Broca's area of the brain. So it is amplifying brain in the parts that you're using over and over and over again. And this, if you've had biology, it's called Hebbian learning. The things that fire together wire together. So to develop an expertise, this is called skill acquisition. So remember, skill can be used in a lot of different ways. And it's gaining the skills that you have to be an expert in whatever you're studying. So there are 3 stages. The first stage is the cognitive stage. Remember that cognitive just means thinking. So this is the hard thinking stage. And that's when you're going to develop a declarative encoding of the material. And so declarative, remember, is explicit memory, very conscious memory. And that's sort of when you're learning all the facts. So you have to have a base. So if we're learning chess, we have to know what all the pieces are and how they can move before we can implement strategy. So you have to really have that sort of categorical memory first. So this is how semantic gets evolved, and then episodic, that same idea. So I'm learning what operations are necessary to perform that skill. So I'm an avid tap dancer. And thankfully, again, no talent hack, so I have practiced a lot. And the first thing you have to do is really learn, other than figure out what these things are on your feet, how to make the 4 necessary sounds. So brushes, stomps, heels, steps, those sort of things, to be able to even do any of the steps. The problem with the cognitive stage, and this is maybe why people give up, is that the knowledge use is really slow. Because you are having to store the things in long-term memory and then pull them out, fix them, remember memory is reconstructive, and then put them back. And so this stage of expertise is the slow one. So if you think about a learning curve, it's got a steep learning curve sometimes. The second stage is the associative stage. You can kind of think about this as elaboration. So it's when we're associating the declarative facts with the skills and making those connections. So we're making a connection between the steps. Steps, remember, can either be tap steps, because I'm talking about tap, or they can be procedural actions like learning how to write, the types of sentences. So this is when we're creating a procedural skill. Remember, procedural memory is that muscle movement memory. In the autonomous stage, so autonomous, the way I think about this is automatic. The procedure to do whatever becomes automatic. So my ability to think about maxi forward steps stops being okay, I've got a step, shuffle, leap, toe, right? That's half French, that's why it sounds funny. Instead, I can just do the action, and I don't have to think about how it's supposed to sound. And that becomes automatic. So I don't need to pay a whole lot of attention, and then my brain resources are reduced because I have this sort of quick and easy set of rules versus having to pull them out of memory. So what does that do to us to gain an expertise? It's good for you, first rule. And so there's a lot of different ways that it impacts other areas of cognition. So we're going to work through all of these one at a time. So the first one is the power law. So as we learn, performance improves exponentially. So that's an upward power curve. As we are practicing these skills, our performance should get better and better across time. And then the sort of reverse is true. As we learn, the amount of time or attention or brain resources decreases exponentially. So as performance improves, the amount of energy, so to speak, decreases, which is good because that makes performance easier. So here's an example of the power law. This would be an example of the performance is improving. So as we practice more going along the bottom, our performance goes up along the top. The amount of energy needing is a reverse curve where it goes down faster. Given enough practice, the time to do a task will approach 0. With the limitation of how fast the machine works. So that's the cognitive processing part. As we age, we do slow down. And if you're talking about an athletic skill, there are physical limits on the muscle system. So let me give you an example of a task. So this is Kohler's inverted text experiment. And what he did was he played on an expertise people already had. So he played on reading and trained people to read inverted text, so upside down text. So he gave some people inverted text and some people regular text and looked at how long it took them to read the text. Without practice, it took the inverted text people 16 minutes. With practice, it took the regular text people, without practice, it took regular text 1.6 minutes. So about 10 times the amount of time. Then he gave them a bunch of practice, and people came down to the same rate. So I could read the inverted text as quickly as I could read the regular text. And then magically, he got people back in the lab a year later, don't ask me how, and what he found was that expertise stuck with them, even though you're likely not practicing reading inverting text very often. And so they found that people could still read quickly at 3.5 minutes. And then the regular reading was still 1.6 minutes. So you see it's only twice as slow instead of 10 times as slow. And then he asked them to retrain, so relearn how to do this. It took them much less time to learn how to do it, and the skill was regained quickly. So expertise sticks with you even though you don't probably practice a whole bunch. So in this day and age, I don't know that we practice writing a whole lot anymore, unless you like to take notes in class, but it's something that if you practice a little bit, you could still do, even though we may not do it as much anymore. Alright, proceduralization is the process where we're moving from declarative to procedural knowledge. So we're moving from explicit knowledge to implicit knowledge. And so we don't really need a verbal recall of the rules. So this is when we're moving from the association stage to the autonomous stage. But what happens that makes proceduralization so interesting is that we recognize the patterns of rules that are going on. And so as you gain an expertise, you're actually learning how to recognize patterns a little better in whatever you're trying to learn. And a little bit of that is called tactical learning. So this is especially useful for studying expertises with like steps. So if you're trying to solve a physics problem or you're trying to beat somebody at chess, there's a sequence of actions. So tactics are any kind of method that accomplishes a goal, kind of strategy, not quite. And what happens is that as we gain this expertise, we learn better tactics, and we can apply those tactics to other things. And then what happens in the brain is as I switch from solving the problem, so having to think about all the pieces, doing very declarative type task, to the implicit retrieval task, you'll see that it goes from the prefrontal cortex, where it's focused attention, bringing up all the facts, to the posterior, the back of the brain, where you're sort of imagining what's going on, to the hippocampus, which is our memory center. So you see the brain switching as you gain expertise as well. It's not just that the activation goes down, it moves to a different location, tied to where our memory systems that's grand central from the memory. Very similar idea to tactics and proceduralization is strategic learning. And so and I really feel like I see this now as I am getting more and more into my research, that you learn how to organize material, especially for problem solving, in a different way. So, when I'm thinking about like sort of linguistic research, and we were recently talking about a paper revision we were working on, and somebody had suggested, well, maybe if you restructure this in a different way. And so taking a step back, I was able to say, well, really we should have done it this way. And that helps us organize this better. And the people I was working with were like, oh, I never would have thought of that. Because there's just a different way to organize the information that helps me solve problems. So why do you do that? Well, as you learn more information, the rules sort of change. When you're learning facts, you're just trying to cram all those facts in, and you slowly start to understand the connections between those facts. And so understanding that the rules that govern the facts can change to make it easier for you. So an example, novices tend to work in a very bottom-up sort of method. So the way they studied this was they gave novice physics students, so in physics, what 23, a very basic one, and then physics experts, graduate students, and faculty members, and asked them to solve these physics problems. And what novices tend to do is they ask, well, what information do I need and how do I get that information? So a very surface structure approach. Experts tend to work in more top-down sort of way, so a more goal-oriented approach. And so they ask, well, what do I have that gets me to a goal versus what do I need to get to the goal? So we're just working from different directions. And the top-down manner is more efficient. So as we become experts, we are, okay, so this is all tied together, strategic learning and problem solving. We just have more information available, and that helps me encode the problem in a different way that makes it faster and more efficient, easier to do. So if you ask people to classify objects, and in this particular example, they didn't ask them to solve physics problems, they asked them to group the problems together in any way. So make categories of these different types of problems. And what you'll see novices do is, well, all of these say something about mass, so we're going to put these together as mass problems. Whereas experts are more likely to use more semantic principles. Well, this question is more about gravity, so I'm going to put all of the gravity ones together. I don't really remember physics, but you get the idea that novices tend to use a very surface, it says this word sort of thing, whereas experts tend to do a more, this problem means this, so I'm going to group all these meaning ones together. Here's the big kicker though. Let's say you gain an expertise. Good for you. You're stuck with it though. So transfer of skill is very narrow. So we will not be able to transfer our skills to similar domains, and often no transfer to different domains. So I want you to think about all the professional athletes that you know essentially that are good at more than one sport. And it's usually people come up with about 5, maybe 2 hands worth of people who played more than one sport professionally. And so that, just because I'm athletic, that does not make me good at all these different sports, especially if you have to throw something. Terrible. I throw like the world's girliest girl. It's terrible. And so because I'm good at tap dancing, that does not make me good at hip-hop. I mean, yes, they're both dance, but I look like an awkward white girl doing that as well. Doesn't help when you're the tallest one, that sort of thing. So transfer skill is very, very narrow, and you'll see this if you try and learn a second language. So we're experts at our own language, our first language. So I'm going to learn another one. Well, I've got 1 grammar's worth and all these dictionary facts worth of language. Why can't I learn this other one? And that's because expertise transfer of skill is almost impossible. So let me give you an example. So what they did was they took kids in Brazil who were street vendors. So they sold fruit on the street. And they either gave them street problems. So if I bought 2 bananas and 3 apples and I gave you this much money, how much would I get back? They did them like this. They were so good at it. If I give them a very similar math problem, so if I have 2 things of this much and 2 things of this much, and I give you this much, how much back? And they're actually pretty terrible at the math problems. because even though they rely on the same underlying idea of math, their skill was so specific to that that understanding of how they worked in their environment, that it didn't transfer across to a similar but not structurally the same kind of math problem. So things that will transfer are considered identical elements. So the transfer of that skill will only be the same to the extent that they have the same knowledge elements. So being good at statistics does not necessarily make me good at math. And then but the times that those have the same structure, I am good at it. Okay. So being good at tap does not make me good at clogging. I am good at soft shoe, which looks sort of like tap, but is not quite really tap. It's got double taps and all these weird movements. So the only time I'm any good at that is when it has the same structure, the same kinds of ankle foot movements. Positive transfer is when we get the skill to transfer, but it has to be the same rules, facts, patterns, and response patterns. So it's got to have that same match, because as you'll see in the problem-solving section, we're pretty terrible at analogy as well. Negative transfer is the reverse. So when I learn one skill, that makes me actually worse at learning another skill, and that's because of interference. So when I learned how to drive my stick-shift car, anytime I'm in an automatic car, now I have to sit on my foot so I don't clutch the brake. So they have that negative transfer there. I'm trying to do what I always do, which doesn't work in this situation. And that's due to interference between the two types of tasks. Okay. So to sum all that up, expertise is the ability to do a particular type of task. It could be cognitive, it could be athletic, and it does a lot of really good things for us within that expertise because the transfer of skill tends to be very narrow.